So here, this is a ternary to decimal uh, convergence. So these are your ternary numbers. Ternary numbers will have only three digits in this number system: 0, 1, and 2. So all numbers you have to represent with the help of these three digits only. So these are the decimal equivalent of your ternary number. So you can see the chart. So 0 decimal equivalent 0, 1 decimal equivalent 2, and decimal equivalent is 2. But for 3, the ternary number is 1 0. For 4, ternary number is 1 1. 5, ternary number is 1 2. Likewise, till 14, you can see all the ternary equivalents, right? Now, what we have to do is the ternary input is given. That means there will be some number, and that number will be in the form of will be in the ternary number system, and we have to divide that number by 5, and we have to check what is the remainder, right? This is the problem. So after getting this equivalent decimal equivalent for first 14 ternary numbers, we will start with the problem. So let's assume that you know that always when you are dividing a number, the you will be having some result, and to that previous result your next digit is concatenated. This is how you are doing in when you are dividing a number. So you are dividing a first bit, whatever is the remainder, to that remainder you are concatenating the next digit, and then you will divide again you will get some remainder, and again the next digit you will concatenate with that. So this is how you are doing. So assume that this is your first state Q0, and we have to generate the Mealy machine. So the output which this Q0 will generate will be 0, obviously, because there will be, before you have not started your division. So always the previous digit or a answer which you will concatenate with the another next digit will be 0 only. That is the reason you got 0. And to this 0, you will be concatenating the next digit. So what are, in case of ternary, what are the possible digits which you can concatenate to the previous result? Those are 0, 1, and 2. So to 0, if this is your previous result, to that 0, if you are concatenating another 0, and then you are dividing it by 5, so what you will get, what will be the remainder? The remainder will be 0, and that is the reason you can see this loop. Now to 0, if you are concatenating next digit as 1, so what will be the remainder? It will be 1, and that is the reason when you are giving 1 as a input, you know that 1 by 5 you will get 1 as a remainder. So you need to transfer to that state which will generate 1 as the output. So that is the reason you are here. Now because you are dividing it by 5, so possible remainders are 0, 1, 2, 3, and 4. Okay, so now when you will give 2 as an input, so 2 by 5 remainder will be 2, and that is the reason you need to transfer to the state which will generate 2 as uh, output. Then same for 3. So when 3 is the next digit, so 0, 3 by 5 remainder is 3, and that is the reason you need to transfer to the state which will generate 3 as the output. Then if 4 is the next digit concatenated with the previous 0, and so 4 by 5 you'll get 4 as a remainder. Okay, so this is the very direct process. If the first digit is either 0 or 1 or 2 or 3 or 4, so this is what you will get. Now assume that your previous, this is the case when your previous result is 0, that is when you are starting with the division. Now assume that your previous remainder is 1, right? if your previous remainder is 1, then what are the possible inputs to that? So when 1 is a remainder, definitely the output generated is 1, because this is what is the remainder. And to this 1 you will be attaching 0. The possible numbers, ternary numbers, which you can concatenate will be 0, 1 and 2. Okay, so when you are having 1 as a remainder and next digit you are concatenating is 0, what number, ternary number, you will be getting? 1 0. So 1 0 when you are getting, it means it is decimal equivalent 3. So to the Q1, if you will be giving the input as a 0, you will be getting ternary number 3, and that will divide by 5. So remainder will be 3. So you need to transfer to the state which will generate the output as a 3. So from Q1 you will navigate to that. And that is the reason. Okay, I mean to say, this is the example and you are dividing it. So if you have 1 as a remainder and the next digit which you are concatenating is 0, so you are getting ternary equivalent as 103, right? And 3 by 5 when you will do, you will get remainder as 3. So you need to have a age from Q1 to Q3 on input 0. Now, similarly, the way here it was a 0, you can have 1 as the next digit possible input. So you'll get 1 1. 1 1 is nothing but the 4. So from Q1, when you need to transfer to Q4. Okay. So 0 and 1, this possibility we have tested. Now third possibility is 2. So it is 1 2. 1 2 is nothing but decimal 5. And when you will divide it by 5, you will get remainder as a 0. So from Q1, you will move to 0, Q0. So this is how it will work. Now, you have given all possible input to Q0, that is 0, 1 and 2. You have given all possible inputs to Q1, that is 0, 1 and 2. Now, similarly, you give all possible inputs to Q2, Q3 and Q4. So when 2 is a remainder, the next digit which you can concatenate is again 0. So you will get number 20. It can be 1. So number you will get is 21. It can be 2. So number you will get will be 22. So check that decimal equivalent, divide it by 5, see what is the remainder, and accordingly you move to the state which will generate that respective output. And by doing this process, you can complete this state transition graph, and this way you can construct your Mealy machine. And from this transition graph, at the end you can design the state function and the machine function, right? So till this step we have completed. Okay, the remaining part I want you to complete now, and then you can check with your final answer.